Okay, so good afternoon, and luckily I'm the last one. So today my name's Ying, and I am from University of New South Wales in Australia. So today what we're going to present is estimating net cost of implementing BIM at different LOD via a neural network. I've got two other co-workers. I don't think they're here. So as I just mentioned in the title, so basically there are three keywords in this part of work. The first one would be building information modeling. I know lots of people in this room has already got some understanding of it, but I will just roughly go through it. So what I think about BIM is a method to manage the project design and building project data in a digital format. And the second one is level of development. So we choose to use the word level of development rather than the level of details. So the level of development is kind of defined as a reference that can be used to specify and articulate the content of BIM. And the third one, which is the last one, which is predictive evaluation, or we can call it ex-ante evaluation, is used to forecast and evaluate the future situations before you make the decision. So our objective is to design a predictive tool to evaluate which LOD comes with the least generic net cost. So what are we going to measure? And what are the composition of the net cost? So we kind of measure the net cost through implementation cost, which are the three items on the right, and the implementation benefit, that's the two on the left. So the implementation costs include installation and maintenance cost, adaptation cost, and training cost. So the benefits are productivity improvement and intangible improvement. In this case, the net cost Rx will be the difference between costs and the benefits. And how are we going to measure it? So we use a standard neural network to help us in calculating. So the input that we are going to put in the neural network will be the cost and benefit we mentioned in the last slides, but the number of input neurons depends on which cost or benefits we are measuring, because for each of them we got different input dimensions. For example, I got 4 inputs for the training cost, about 5 for the productivity improvement. And the output that is on the left, the blue neurons, that they will be different LOD levels. So the output will have 4 neurons. So what can we get from the neural network? It will be a posterior probability of LODI has been adopted. I have to clarify that not all neural networks' output can be considered as a posterior probability. It just works for several particular neural networks. For example, the one that I am using is trained with backpropagation and stochastic gradient descent. So, and now I just get you an example of how my input will look like. So I collected my data by using a questionnaire. So this is about productivity improvement. I got 5 in each of them, and these will be my input. This will be my input neurons for the network of productivity improvement. And for each of the costs and benefits, I got 1 neural network each. So in total, I got 5 neural networks. And they are measured from 1 to 7. So, yeah. This slide, I just decided to include these slides yesterday because I want to talk about my my own experience to train and tune a neural network, especially in a supervised learning. What I think is, in a supervised learning, or the purpose of machine learning, I think is just to learn to predict. So basically, there are two tasks in this machine learning. The first one is learning, and the second one is prediction. So the first thing that we need to do is to learn from the previous data. And we have to test out whether our model will work for our future data, which we don't know. So I think we should split the data set into 3 sets: train, validation, and test, with a ratio at 6:2, and then scale the data. So the thing in the box is how I train and tune my neural network. So I'm using a constructive approach to tune it. When I will use a graph to explain what is happening in the box. So the horizontal axis is the number of neurons, or you can call it layers, and the vertical axis is the arrow. So it doesn't matter how complex your neural network is, the training arrow should keep decreasing. But the validation arrow, it will decrease first but increase later on. So the best neural network, we think, it should be when the validation loss reaches the bottom. And we have some assumptions as well. Okay, because as we mentioned, what we can obtain from a neural network is just a posterior probability. So we are assuming if we have more benefits and less cost, so a company should have a higher probability to adopt BIM at a higher LOD. And the second assumption is that the more cost and the more benefits and less cost will lead to a company to experience less net costs. So I show it in a table. So this is the case. So the case study example is what I showed in the previous slide. So the case study to the productivity is shown as 45544. So as we mentioned it earlier, we have already scaled data. So I am using the scaled average level here as the average level of the whole industry. When we are scaling the data, it should follow a normal distribution. Okay, so and I'm just assuming that this is just an example. It's not a real case thing here. It's not happening. So the average level for the productivity improvement could be like this, and we are comparing the case study and our average value, and then we got the symbols in the last row. So basically, it's saying that the case study should experience less in productivity improvement, which means they are less likely to implement BIM at a higher LOD and more net cost. But we cannot assert that because it has got five input neurons, but for some of them, they got 4. Also, we have to compare the sum of them. So here I am assuming each of the questions have the same level of importance. So when I'm comparing here, again, so it has confirmed what we thought before. The case study is experiencing less productivity improvement. So here comes what we think. We think this company is less likely to implement a higher LOD and more net cost. And then we assumed a function that is Rx. So the Px, as I mentioned earlier, is the posterior probability that we get directly from the neural network. So for each of the output neuron, they will get a PX. But we only think that that company is going to adopt LOD 300 if LOD 300 has got the highest posterior probability. So we are using the maximum of the posterior probability minus the one of others and times the scaled input. And we tested out in a case study. The case study is selected from a test set. So it's a small infrastructure company that has been implementing 3D visualization at LOD 350 for 2 to 5 years. So based on our calculation, it comes this table. So in this table, there are some negative numbers inside, which means that they have negative in cost that is positive in benefit. So when it's 0, it's almost balanced. So in terms of the net cost, we think that LOD 300 is the most economic one, but the one that they implemented is also beneficial, but not the best one. And then we did some sensitivity analysis to see which kind of cost is the most sensitive cost to the whole net cost. And then we found the adaptation cost. So when the adaptation costs start increase, the net cost will also start increase. Okay, here's our conclusion. So we think that implementing BIM at entire IoT doesn't equal to more benefits. And the net cost is quite sensitive to the adaptation cost in our study. No, in our case study. So, and we think that this method is more practical because it has less reliance on the project data. So what are we going to do in the future? We want to look at some stochastic factors and then put that together with the neural network. For example, the market demand. And also, I want to try some ensembled method to improve the accuracy of the neural network. And that's it. But before we're closing, you know, we are kind of caring and considerating students, and we would like to create a very friendly environment for the PhD community. So here's something.
Actually advertised a couple of positions which should relevant to this conference. They are closing pretty soon, so it's in the areas of BIM, SIM, artificial intelligence. So I just wanted to bring this to your attention. So if you want to talk about this, I'll be around. Thanks.